Now, the first thing we're going to revise to do with algebraic expressions is the terminology, right? That's where we started with this whole thing. We want to refer to stuff with the correct terminology. So let's get going. All right, so this is an algebraic expression. We know it's an expression because there is no equal sign. There is no left-hand side and right-hand side. We just have a bunch of terms. All right, that makes it an expression instead of an equation. Now, out of my components of the expression, let us start with coefficients. Our coefficients are the numbers that are in front of my variables. And in this case, we have a 3 and a 5. The numbers in front. So the coefficient is not 3x, it is just 3. And this one is just 5. 9 or -9 cannot be a coefficient because there is no variable next to it. Okay, it's sitting on its own. Instead, we call 9 a constant. Constant means does not change. The value of 9, -9, will not change. So even if I change my x and y, that will not affect my -9 in any way. It's constantly going to be -9. In contrast, variables always change. That's what the word varies mean, right? Like it varies, it depends on the scenario situation. Variables do not always have the same value. For the first question, you might get x is 2. Then the next one, x is 5. And the next one, x is -100. So that's what variables mean. It means it varies, it changes, depends on the situation. Okay. And then, of course, the last thing that is important is, my terms. How do we know what terms are different or when do we have a different term? They are separated by a positive and a negative. Okay. So in this case, we have a positive and a negative. So my terms will then be 3x, 5y, and a 9. All right. So having said that and having gone through our little summary of rules, I want us to fill in this table. First one, my expression is x squared minus 4x plus 3. How many terms do you guys see there? Nice, Alice. We have 3 terms. And for those who are confused, that's because terms are separated by positives and negatives. Great. The coefficient of x is what? My coefficient of x is, we have 3 different answers here, which is why we're doing this. It is -4. Now, be careful with coefficients, okay? If I say the coefficient of just x, I really mean the coefficient of just x, regardless of the fact of we might have a x squared, x cubed, xy. That's not what I'm asking for. I want the one with just x. And in this case, another mistake that is common that I saw in the chat, you have to take your coefficient with your symbol. It is not a 4, it is a -4. All right. So those are things to look out for. What is my constant for the first one? The number that will not change even if x changes. That is nice, +3. Thank you, guys. And then what about the variable here? I only have x. Okay, x is the same variable. If I said to you x is 2, you are going to substitute 2 over there and over there. It doesn't matter what the exponent is. The variable is x. So you do not have to list x and x squared and x cubed and x this. The variable is x. It's actually how many different variables do you see? That's how you need to think about it. All right. Now, I forgot to mention something very important when we started. When you are answering questions like this, you must always simplify first. Check if you can simplify first. It's the same thing with that table. Do you guys remember the table where we were like, take all that apply? Is it a natural number, whole number, whatever? You always first simplified it. Like if they gave you a square root of 9, you went and made it 3. Do you see what I mean? That's all right, Umpa, welcome. So you always need to remember in such cases to simplify. So let's look at the second expression. Is there anything we can simplify there? Simplify means add like terms and stuff like that. It does not mean start factorizing and all of that. So no, we cannot simplify it, right? So then let's move on. How many terms do we see for the second one? Nice, we see 4 terms. Great. My coefficient of xy, see, I'm very specific. Coefficient of xy is nice. It is a positive 3. What is my constant in this case? A 4 or positive 4. And my variables, what different variables do we see here? X and Y. Great, guys. We have X and Y. Great, let's look at my third one. Can I simplify that third one in any way? Yes, what can I simplify? I'm hoping you guys don't fall into the trap that my learners do at school. Ha! Jason didn't fall for it, but Alice did. This is one term. So you first multiply before you add the like terms. Be careful. We like this question because it tricks you guys. Okay. Must be woke, guys. Okay, so it's very common for us, especially if you're working fast. You just look at it and then you see x and x like terms. But this multiplication in the middle here, BODMAS still counts, right? You first have to multiply that before you go and add anything. So let's first multiply. What's negative 4x times 3? Nice, this is negative 12x, but I think I'm going to have to finish off the sum on the side because there's no space there. So then my new expression will be x squared y because I can't do anything about it. But now I do have like terms and they are negative 12x plus 2x. What is the answer for that? Nice. It's negative 10x. Then I have plus 9 and minus 7y. Is there anything else we can simplify here? I don't think so. No, there isn't. Thanks for checking. Great. Now that we have simplified, we can answer this question. How many terms do we have here? We have 4. What is my coefficient of x? Just x. Nice, Alice. Negative 10. Nice, guys. You guys are getting it. What is my constant? A 9 or positive 9. And what are my variables in the specific expression? Again, we have x and y. Great. Wonderful, wonderful. Okay, last one. Is there any way I can simplify this? No, there isn't, okay? They're not like terms. We have an m squared and an m. So there's no way we can't add them. Do not factorize whatever you do. We cannot simplify. Okay, so let's look. How many terms are there then? Now that we've established that, we have 2 terms. My coefficient of m squared, there's nothing in front of it, which means my coefficient is m squared. Careful. My coefficient is 1. And now, if you do not see a constant, guys, what is my constant there? It cannot be 1 because I would have written plus 1. Nice, Alice. It is a 0. So if you cannot see, it's the same thing if I say to you, what is the coefficient of m cubed here? Is there a m cubed in this question? No. So then the coefficient is what? It is a 0 because it's not there. Nice. You guys get the point. And then my variable for the last one, just m. Remember, whether it's m squared, m cubed, It's just m. What about 1? If there was a 1, Jason, then there would be a plus 1 over here. Does that make sense? And if there is a coefficient of 1, then it looks like this one over here. So it will be m cubed, but you will still see it, is my point. Like it will still be in the sum. But if it's not there completely, then it has to be a 0. Okay, because remember, we don't write zeros. You're welcome. Okay, let me zoom out so we can take a screenshot. Geez, zoom out again. There we go. And then we're moving on to the next part of today's lesson, where we are going. If I write 1m squared, but remember, we're writing just the coefficient. When you write coefficient, you do not write the variable as well. If I have negative 4x cubed, and what I ask you what the coefficient of x cubed is, it is just negative 4. You do not write the variable. So the coefficient is negative 4. All right. It's like saying what's in front of x cubed. So you can't say negative 4x cubed is in front of x cubed. I hope it makes sense. All right. I like that we have questions today. We're moving. You guys are hyping me up. All right. Let's get going. Now, I'm going to have a little bit of a summary of factorizing. Now, I know there's one more method of factorization that is not here, and that is grouping. We haven't really done it, okay? So I stuck to the ones that we have done fully and extensively. First thing is taking out a highest common factor. Now, I'm going to write here as a little bit of an NB or a tip or whatever you want to take it as. This better be the first method you look out for. So this must be the first one you look out for. All right. So even if you have a trinomial, look if there's a common factor. Even if you have two squares, look if there's a common factor. You start with common factor. Always, 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 always. Okay. It's going to save us a lot of trouble. Do you guys remember the trinomial we had, which became very simple because there was a common factor? Let me give us an example. Okay. If I have a 2x squared plus 4x and then minus, let's say, a 10. Okay. And then if I take out a common factor, this becomes x squared plus 2x minus 5. Do you see that it will be much easier to factorize this bracket than it is to factorize the first one? That's why I say get into the habit of first looking for a common factor. All right, guys. I hope I have burnt that into your memory. Always look for a common factor first. Great. Now, common factor, you look at what do both my terms have, okay? What can I divide both my terms by? In this case, there was a 2 and a 4, which means they both have a 2. And then in your bracket, as you know, we wrote what was left. All right. If this is still a bit confusing, go a few lessons back. We did do factorization in great detail. Okay. My second one is the difference of two squares. Once again, what does the word difference mean? Which operation am I working with? A minus. Okay. So one thing you guys get caught up with in a test is if I write x squared plus 16 and you guys see two squares and you get too excited. Don't get caught up in that trap. Trust me. Better make sure it is a difference. This is a sum, not a difference. So this doesn't work. Okay. So difference of two squares. We said we find the square root of my two terms. And those are the ones that go into my brackets. So x and 3. Then all you remember is you have two different symbols inside. Okay. And then the last one finally is a trinomial. What does the prefix tri mean? It means 3. So this works when you have how many terms? 3 terms. All right, guys. Once again, I'm reiterating, you first look for a common factor. Great, let's get going. I'm going to do these quickly as just a nice warm-up for our brain. Okay, what method of factorization are we going to use there? Nice, Alice, which means I'm going to open my two brackets. What will my two factors be inside my brackets? M and 3. Great, and then my symbols. I'm going to have a plus in one and a negative in the other. Wonderful. All right, let's go to B. Has anyone looked at B yet? What is the first thing we look for? Highest common factor. Do we have a common factor for B? Yes, we do, and it is M. Nice. It is M. They both have an M. In case you can't see it, there and there. Great. Now, if I take out M, what is left for my first term over here? A 2, an n squared, and then plus what will be left for my second term over here? Nice, a 3. Now, just because this is an n squared, do we have a difference of 2 squares here? No. So we are done factorizing. All right, let's look at C. What are we going to do with this one? Firstly, is there a common factor? Let's look. Y squared minus 6y plus 8. There is no common factor, right? So how are we going to factorize C? It's a trinomial. Okay, there are 3 terms. So that means I will open up 2 brackets. Great. What is my first factors? Well, my first set of factors that are going to give me y squared, y, and y. What is my first symbol according to this one over here? A negative. Does that mean I will keep or change the second one? It means change. So then my second one is also a negative. Nice. I wanted to see if you guys remembered. Nope, some of us didn't remember. Remember, guys, keep or change the second one. So if we're changing the second one, that means it becomes a negative because it was a positive. Are we? All right. So the keep or change is not for the first symbol. It's for the second one. All right. Now let's look. We're going to work with factors of 8. What are my factors of 8? 2, 4, 1, 8. Now I want a set of factors that are going to give me negative 6. So which ones am I going to use? 2 and 4. And of course, we like to check. So I'm going to check negative 2 minus 4. How much is negative 2 minus 4? Negative 6. Is that what we are looking for? Yes, indeed it is. And let's look at the last one. D. How are we going to work with D? Highest common factor. Nice. So what is my common factor in D? X. So if I take out X, what's left for my first term? I have a 3X. Second term, negative 4Y. And my final term, plus 20Z. Is there anything else that we can do with that bracket? No. Great, guys. I think that went well. It was just a revision. And then we went on to do expansion. Okay, so now we're going to learn the difference between the two words, factorize and expand. Factorize means put it into factors, but if you look at expansion, they are already in factors. I have a 3x and an x minus 2. So then what do I have to do here? If I have a monomial times a binomial, what's my magic word here? What do we call it? It is timesing, but how do I times a monomial and a binomial? Nice, Jason. Distribution. Great. So then my 3x must be multiplied with everyone inside the brackets. What if I have two binomials? So a bracket times a bracket, like so. Then what do I do? What do we call it? Nice and clear. This is FOIL. All right, so factorize means you do one of the following. Common factor, difference of two squares, trinomial, or grouping. Expanding means you're multiplying it out. So you're either distributing or you're foiling. Okay. The other important concepts we need to remember is adding like terms, substitution, and when you have a monomial times any number of terms. But that is the same as the first one. So if I have 3x times 2y plus 4 minus 10x squared plus 7x. Okay, it doesn't matter how many are in the bracket. You are still going to distribute this guy. All right. Now, we have an interesting question over here. Interesting question. It says, consider this expression and do two operations with it. Okay. That's what that is, Intle. Monomial, mono, it's alone. Polynomial means there's many, 1, 2, 3, 4. Then you distribute. Do you see that's what I was talking about now? Monomial with the polynomial, excuse me. Polynomial. Divide. Do you mean plus 3x minus 4 divided by x, like so? Then remember you divide them. So you're going to say x squared over x plus 3x over x minus 4 over x. Then you look at x squared divided by x is just an x plus these x's will cancel out plus 3 minus 4 over. Obviously, you'll have a better question than this, right? But that's how you do it. You separate them. Okay. I'll take notes of this endly and maybe we can do it in the next lesson. How's that? All right. Now, let's see. And endly, that is part of simplification. Yeah, that's part of simplifying. All right, so let's look what we have here. I'm going to move these guys down a little bit so we can concentrate. So the first instruction says expand and simplify the expression. And my second one says factorize my expression. Those are two very different instructions. So let's start with expand and simplify, okay? I have x squared times x minus 3 minus 4 times x minus 3. Great. We are not factorizing, okay? As said, when we are expanding, what are our options for expansion? What are our options for expansion? Foiling or distributing. All right. Now, which one are we going to use here? Can we foil? No, we can't. So we're going to use distribution. So this x squared must be multiplied by everyone in this bracket. Negative 4 must be multiplied by everyone in this bracket. Now let's get going. What is x squared times x? X cubed. X squared times negative 3 minus 3x squared. We're done with the first brackets, and then negative 4 times x That's negative 4x. And negative 4 times negative 3. Positive 12. Nice. Is there anything else we can do here? Are there any like terms? No. So we are done. Okay. That's what expand and simplify means. You do not go back and factorize and end up here. That's when you know you have done the wrong thing. The second one, however, is telling us to factorize. This is minus 4 times x minus 3. Great. What is the first thing we look out for when we are factorizing? First thing we look out for a factor has common factor. Is there a common factor here? Yes. And what is my common factor? It's a common bracket. The whole x minus 3. Do you see that, guys? So I'm going to take out my whole x minus 3 because it's a common bracket. What's going to be left for my first term? First term, x squared, thank you. And my second one, it's a minus 4. Are we done factorizing here? No, yes. Those who are saying no, what else can we do here? Difference of two squares. It said factorize fully. If you didn't see that, you were going to lose a mark. There's a difference of two squares over here. All right. So let's get going. So I have x minus 3. Great. And then x squared minus 4. So I'm opening my two brackets. What's my first term in my two brackets? An x and an x. And then my second term in my two brackets. A 2 and a 2. And then we have a positive and a negative. Do you see the difference, guys? Okay, let's have a thumbs up, thumbs down. We haven't had them yet since this lesson started. I think we had one. There we go. That's a healthy amount of thumbs up and, well, thumbs up. I haven't seen a thumbs down yet. Great, guys. Great. Now, let's get practicing on all of these concepts. Obviously, this one is telling you that you're going to factorize. I'm going to choose the ones that I feel like are interesting. We're going to challenge us a little bit. Just a little bit. All right. So let's get going. We definitely have to do number 1. Oh, everything here is a challenge. I like it. Okay, you know what? Let's just get going. Everything is a challenge, which means I want to do most of them. Let's get going with number 1. X squared plus xy minus 12y. Why is this a challenge? Y squared. Why is this a challenge, guys? We have an x and a y. So what method do you think we're going to use here to factorize this? It's a trinomial, so you guys might not trust me, but it is. Okay, so I'm going to open my two brackets. Let's start with factors of x squared. X squared, we have two x's, right? X and x, beautiful. First symbol, according to this one over here, I have a positive, and does that mean I'm going to keep or change the second one? Keep. So then what's my second one? It's a negative. Beautiful, guys. Now, we want factors of 12 y squared, not just 12. All right? Let's see. Let's start with factors of just 12. Factors of just 12. I'm going to provide the first one. 1 times 12. 4 times 3. 2 times 6. Is that everything? I think so. 1, 2, 3, 4. Yes, it is. But I have a y squared over here. But that's not a biggie, guys. Because what is the factors of y squared? What are the factors of y squared? So y and y are just going to go in there. Do you see, guys? It wasn't that deep. And what two factors are going to give me a positive xy? 4 minus 3. So then I have a positive 4 and a negative 3. Now, if you don't believe me, we can do outer and inner. Outer is x times negative 3y. And inner. So outer, what's negative 3y times x? It's negative 3xy. Inner is 4y times x. That's positive 4xy. So what's negative 3xy plus 4xy? It is xy. Do you see it wasn't that deep, guys? I saw a question. So if we have a negative, we change. And if we have a positive, we keep. Yes, that's how it works. But remember, we're referring to the second one. So this positive will firstly, we're going to use it 2 times. Firstly, we're going to put it in the first bracket. And then we're going to decide whether I'm keeping or changing the second symbol. You see? You're welcome. Okay, do you see how this works, guys? So even if you have an X and a Y, you guys can do it. I hope you love that question like I did. Okay. Let us look at 5. 5 is very interesting. 5. X plus 1 squared minus 2 times x plus 1 minus 8. What is going on here, lovelies? How many terms do I have? I still have 3. 1, a 2, and a 3. Okay, great. What method of factorization am I going to use here? I remember a few lessons ago, someone told me a method that could help us solve this. Because does anybody remember what that method was? I can't remember if it was you, Alice. Does anyone remember that method? It could have been. Ha! Entle. The K method. Entle, can you describe to us what the K method is? You guys are geniuses. You guys are geniuses. You're just doing the right thing. Okay. So the K method, basically, I think Entle's still typing. When you replace brackets with K. So it doesn't have to be K. Okay, guys. But there's a reason we use a K method because of where you are going in math. Those of you who are going to take it in grade 10 and 11 and 12, just stick to K. Doesn't have to be a K, but stick to K. There's a reason we do that. So I'm going to say this bracket here. So let x plus 1 equal to K. Are we with me? That means this whole bracket is K. So then it looks like so. K squared minus 2K minus 8. Does that not look better to factorize? That looks much better, guys. Now you can see the trinomial properly. And let's open my 2 brackets. Okay, so what will my factors for K squared be? K and K. Okay, okay, that was, oh, I see, I keep saying okay, and I'm confusing myself with the K in the question. Okay, First symbol, according to the symbol in my expression, it's a negative. Does that mean we keep or change the next one? Change, so it becomes a positive. Great. What are my factors of 8? I have 2 times 4, 1 times 8. Great. Which of these factors are going to give me a negative 2 here? Which of these are going to give me a negative 2? 2 and 4. And my 4 has to be negative for it to work. Now, the only trick is you need to remember to go back and change your K to your brackets. Are we with me? So then we have an answer, K minus 4 and K plus 2. So then you open your brackets and you say, then it's X plus 1 minus 4. I don't know what was that. And X plus 1 plus 2. Then you check if you can simplify it. Okay, there's nothing in front of my bracket that I have to multiply, so I can just take them away. I can take them away. So we can just have X plus 1 minus 4 and X plus 1 plus 2. What is X? No, what is 1 minus 4? 1 minus 4. That means the first bracket is X minus 3. And the second one is X. And 1 plus 2 is plus 3. Ooh, how interesting, guys. How lovely of a question. I never underestimate your intelligence ever. That was brilliant, Entle, for knowing the K method and recognizing it. Not only knowing it, but recognizing it. Wonderful. Well done. And then, of course, I'm going to have us do number 6. Because why not? It was beautiful, though, Entle. Don't you agree? If you can do this, you can do the easier ones. But don't overthink. Yeah, 6 is beautiful, isn't it? 6 is brilliant, guys. Equals. Great. What are we doing? Can I do anything with my square root right now? Can I do anything with that square root? Okay, Alice says yes. What can we do with the square root? Can we do anything as it stands, this question? No. Why can't I split my square root, guys? Think of our rules when we did exponents. If I have x squared plus y squared, all square rooted, is this the same? Is the answer x plus y? Is my question. Is the answer x plus y? No, you cannot split a square root if you have a positive or negative. You can only split it with times and divide. Remember the distributive law of exponents. So if you have, let's say you have this, 16 over 25. Then you can say this is the square root of 16 over the square root of 25 because we are dividing. Make sense? And if you have something like x squared times xy, then you can say the answer is xy because you are splitting it. But if you have pluses and minuses in between, you cannot split that. Geez, what's going on with my reason? You cannot split that square root. That square root needs to stay there. So what's our only other option if I cannot use my square root as it stands? If I cannot use a square root, nice, we factorize the trinomial. So I'm going to open my square root here. I have 2 brackets. Great. What are my first factors over here? X and X. My first symbol, according to the one in the question here, it's a minus. Does that mean I'm going to keep or change the second one? Change it to a negative. Okay, we're getting this finally, okay? Let's look at factors of 64 that add up to 16. Nice, Alice. 1 times 64, 8 times 8. We don't even have to go any further than that because they are both negative. So it's -8 minus 8, and that's going to give us -16. Do you guys see that? In case someone wants me to check, -8 minus 8. This is -16. Great. Now, I have a factor repeating itself. So how can I rewrite that factor? How can I rewrite something that's repeating itself? I can just say x minus 8, nice Alice, squared. And now what happens with my square and my square root? They cancel out, so then my answer is just x minus 8. Is it necessary to do the plus minus? Let's see if we are listening in class. Alice says yes. What does everybody else say? Nelson says yes as well. When did I say we say plus minus? Someone in my DM said no, and he's correct. But I want to know why we do not do the plus minus in this case. Does anyone have notes that they can check and remind us why I said we do not do plus minus? Ha, Alice, beautiful. The square root was already part of the question. Okay, we did not decide to square root. And when they gave us the square root, they already told us it's positive because they didn't put anything in front there. Do you see that? So remember, only put a plus minus if you introduce, I don't know why my handwriting just went soft, introduce a square root. All right, guys. How were those questions? Lovely, lovely, I hope. Let's have a thumbs up, thumbs down on those questions. We still have time. We still have time. I'm not going to let you guys go. Never. All right, I see thumbs up. If nobody has a question, we can move on. Do you guys want a brain break quickly? Then we can come do like one last question and then like call it a day. Okay. Let's see. Okay, I'll go up just now, Nelson. There we go. Please take screenshots so that we don't go up a lot of times. There we go, there. All right. Can I have hands for my brain break, please? In the meantime. Nobody wants to speak to me, but you guys want to brain break. There we go, Alice. All right, Alice, would you rather never wear deodorant or have really bad dandruff?
Okay, okay, this is both awful. You see, if you have dandruff, you can wear a wig. But if you see deodorant is your wig. So if
The
you don't have
itch,
deodorant, you don't have your wig. So I guess bad dandruff.
the itch under your wig, Alice.
But it's worse. You know when you smell, people talk about you smelling.
Oh my
Yeah,
goodness. Oh my
that's
God.
worse, I think.
Okay. All right. Alice has made her point, guys. I surrender. I'm not gonna argue. Everyone seems to be choosing bad dandruff. What's everyone else saying? Come on, guys. There's so many of us in here. The rest of you are just quiet. Why so sad? You can't hide the deodorant. Hey, I don't know. Maybe, I don't know. Maybe there's some other solution. I don't know what people use. The second one is, would you rather have 4 days of school that are 10 hours long or 5 days that are 8 hours long? Currently, we do the 4 days, the 5 days thing. So would you rather move it to 4 days? But if school starts at 7, that means you're going to end at 5. So just think about that very carefully. So you guys are okay with the 5 days thing? Wow. Nobody wants less days. Okay. Next one, would you rather cover yourself in peanut butter or ketchup? Jason, ketchup is so acidic. Can you imagine it in your eyes? Oh my goodness. Charlie, hello.
Hi.
What do you prefer, Charlie? Oh, Charlie's mic stopped working. Ketchup would smell rancid. Oh my goodness. I'm dead. I'm actually dead. The last one, would you rather be allergic to chocolate or allergic to bread? Or anything that looks like bread. So you can't eat pizzas, you can't eat burgers, you can't eat sandwiches, you can't eat any of that stuff. I would rather be allergic to chocolate. I don't care. Hello, Nelson.
Hi, ma'am.
What is your choice for this one?
I think I'd rather be allergic to bread. Sorry, chocolate. Because,
Oh, okay. We're the same. We're the same.
yeah, because you need bread. Like, bread has more nutrients than chocolate. Like,
And
can ruin.
besides that, guys, can you imagine having to find meals that don't include anything that has to do with bread? So what are you gonna eat tomorrow, like every day? Imagine you're going to Skaftin. What are you gonna eat, guys? Hi, guys. Nope, I'm with Nelson on this one. I'm with Nelson on this one. I do not have the energy. I think also what helps me is I don't have a sweet tooth, so I don't mind giving up. I actually don't care. I don't eat it that much. So if I gave it up, it wouldn't make a difference. Guys, I'm the person who keeps chocolates until they turn gray. Do you know when you keep chocolates so long that it turns gray? Like you open it and like it's no longer brown. So you can tell that I'm not a person who likes chocolates. I don't care. It says, ew. Did you guys even know chocolate turns gray? Well, now you know. Now you know. I keep chocolate for a very long time. I don't have a sweet tooth. Ah, it's fun. Alice, I eat ice cream, but I eat vanilla. I don't eat chocolate. So anything with chocolates in J, it's fine. Alice, Alice. Alice has a comment that trends every single day, every single week. I can't believe this. Okay. Wow. Okay, guys, let's expand. I think let's do this one. It's more eventful, and then we can call it a day. How's that, guys? Expand and simplify. So we've learned the difference between expanding and factorizing. Expanding means you times things out. Factorizing means you do stuff like foiling common factor. Okay. So let's get going with this one quickly. Okay, I have 2 times a bracket squared plus a whole bracket which has 2 times x plus 2 all squared. So for the first one, am I first going to distribute the 2 or am I first going to square my brackets? Think of BODMAS or alphabet mass or PEMDAS. I've seen so many things. I can't even keep up anymore. That's right. We first need to square, right? So I'm going to leave this 2 outside. Times x minus 3. Another tip, I said you rewrite everything you're not working on. You guys have a weird habit of doing things piece by piece and then putting them together, and then you forget to put all of them together. So whatever you're not working on, you rewrite it just as it is. So let's square. How do we multiply 2 binomials? 2 binomials. Hi, guys. FOIL. Great. So first is x times x. So that is x times x squared. Outer x times -3. That's -3x. Inner again is -3 times x, which is another -3x. And last is -3 times -3, which is +9. Nice. Plus, I need to work inside my bracket here because the square is outside, right? And this here we squared first, but here we're doing brackets first. You always look what is inside my bracket that I can simplify. So let's distribute my 2. What is 2 times x? 2x plus 4. And this is all still squared. And since it's squared, I'm going to write it in the expanded way so that we can expand it in the next 2x plus 4 in the next step. Great. Now, what am I going to do with my 2 that's outside here? I'm going to distribute. Great. 2 times x squared is 2x squared. 2 times -3x is -6x. Another -6x plus 9. I'm going fast because I'm looking at the time. All right, and then we have plus 2x times 2x, which is going to give me 4x squared, plus 2x times 4, which is plus 8x. Is it not 18? It is. Sorry, Entle, 18. Yes. Okay, so this is 8x, 4x squared plus 8x plus another 8x plus 4 times 4, which is 16. Now let's look at like terms, which we have a lot of them here. I have a 2x minus 6x minus 6x plus 8x plus 8x. 4x squared seems like it's on its own. There's no other x squared. And then we also have plus 18 plus 16. So let's get going. Let's start with x squareds because that's how we usually start. It's just 4x squared. And then, okay, what is 2x minus 6x minus 6x plus 8x plus 8x? Let's get working. 2 minus 6 is -4. Minus another 6 is -10. Where's it is? Geez, Entle. Guys, you see when we say don't rush in life. 2x squared. So the 4x squared does have a like term. It is 2x squared plus 4x squared, which is 6x squared. Don't rush. -6 minus 6 is -12. Plus 8 is -4. Plus another 8 is +4. X, I almost forgot the 4x. And then 18 plus 16 is equal to 34. Thank you, Alice, for doing that because my brain was stuck. Okay, we can call it a day.